So then an alternative method that you can use would actually be DBSCAN, which is density-based spatial clustering of applications with noise. And this is a very highly cited method. It was first proposed in 1996. And since then, it's still pretty frequently used and it's well cited. And essentially, this method approaches clusters as these high density regions that are separated by low density regions within some data space. And this requires two parameters to run. So you need epsilon, which is essentially a radius around each data point. So you can think of 2 points within each other's radius being considered neighbors and part of the same cluster. And then you also need a minimum points threshold, which is essentially the minimum number of neighbors that need to be required for a certain point for it to be seen as a core point, which will help with the clustering later, and I'll go through that a bit more in detail. But as I kind of already alluded to, because DBSCAN looks predominantly at the density of data points, it's much better at handling irregularly shaped data. So if you think about data sets that have very different size clusters, this is going to be able to handle that, or if their shapes are not spherical, this is also going to be able to handle those data sets. So a note on the DBSCAN parameters, you can do a lot more research into this on your own if you're really interested in using DBSCAN, but epsilon is ideally chosen based on some prior domain knowledge. This is not often very intuitive in biological settings. So you can kind of determine it with a k-distance plot, an example which is on the right. And basically, you just want to calculate the distance of each point to its kth nearest neighbor. And one common rule is you can look at like the min points minus one nearest neighbor. And you're looking for kind of this elbow in the plot where you know that the majority of points are within this distance of their kth nearest neighbor. And so you can set that as epsilon. But generally, the values should be minimized when in doubt. For min points, one rule is that you can use just 4 for many 2-dimensional, but generally you want min points to actually increase as you get data sets that are larger, noisier, or higher dimension. And you can think about that kind of intuitively as if you have a lot of points, then clusters are probably going to also be larger, so you want more of those points to be counted within a cluster. So DBSCAN kind of starts by finding these core points. And in this figure, they're labeled as, well, one is labeled as A, but you can consider all of those red points to be core points. And these, as I briefly mentioned earlier, are just any points that have more neighbors than the minimum points threshold. And core points are assigned to their own cluster if they're not already belonging to one. So they kind of serve as their own center of a cluster. Essentially, for each core point, you then want to identify all of the density connected points. So if 2 core points are next to each other, then they're connected. They are considered to be density connected, and they are considered to be merged into one cluster. However, if, for instance, A neighbors B and A neighbors C, then B and C are also neighbors or density connected. So in this plot below, you can see that it's kind of a transitive process so that all those 2 yellow points are also density connected with all those core points and to each other. And then once you've gone through that process, any remaining points that have no assigned cluster are considered noise. And these are essentially going to be outliers that do not count as part of any cluster. So then the end goal is that you're looking for these clusters through first identifying these core points, such as A or the red points in the plot below, which have more neighbors than minimum points, and then are also separated by areas of lower density. And those lower density areas are going to be determined by your border points, which are B and C, which are non-core points, so they do not meet minimum points threshold, but they are density connected to a core point. And noise points are any points external to any core points reach, as I mentioned before, and these are considered outliers. So you can think of these clusters as core points surrounded by border points, and then noise points are basically external to any of those clusters.